Polls are endemic in modern life. Pollsters seek our opinions on anything and everything. Our opinions on toothpaste, on the newest video game, on the new movies, on a film star, and especially in politics. There is perhaps no other place where polling and opinions get so fraught with emotion. And for the reasons I've just given you, relatively small polls can give us accurate results with high confidence, except when they don't. A case in point, apparently, was the bitterly contested presidential election of the year 2000. The protagonists were the Republican George W. Bush and the Democrat Al Gore. The peculiarities of the U.S. presidential election system meant that states were allotted to presidential candidates on a winner-take-all basis. So whoever won the popular vote in, say, Florida would then win the state of Florida. The election was very close, and everything then hinged upon which of the two candidates won the state of Florida. As the votes were counted, polls were being reported in real time on the TV networks. Now, why bother reporting the polls, say you? After all, within a day, we were going to know the result. But we are an impatient race. We'd like to know the answer before the answer is actually provided to us. And so, pollsters camp outside election booths and query people who voted, who did you vote for? You now have a captive audience. You see, people have voted, they're coming out of the polling booths, and so it's very easy to ask them questions. So these are called the exit polls, and you can very quickly engender a large amount of data, much more than the small numbers we had posited using Chebyshev's inequality. By 10 p.m. that evening, the networks had called Florida for the Democratic candidate Al Gore, and therefore the presidency. But by midnight, doubts were creeping into their pronouncement, and by 2 p.m. they had reversed course and said, oh no, the state of Florida was actually won by George W. Bush, and therefore the presidency now is going to go to George W. Bush. Remember, this was actually the pivotal state. This battleground was going to determine who won the election. Now, what could possibly go wrong? Have I been telling you a big fib? By 10 p.m. already, millions of votes had been counted. Not 1,000 or 2,000 or 3,000, but millions. And I've already told you a small sample should give us good estimates of the proportions. Which proportion of the populace is going to go to George W. Bush and what proportion of the vote is going to go to Al Gore? We should already have extraordinarily good estimates. And yet, apparently, it was not enough. By 2 p.m., millions of the votes had been counted, and the election had swung the other direction. And by early morning, the networks had left the field in disarray. They said, we don't know who won. And by this time, almost all the votes had been counted. Something seems to have gone badly wrong. Was it with the mathematics, or was there something else going on? To come to a right understanding, we're going to have to dig into a little bit of the details of what was seen in Florida in that year. So, in that year, the number of votes that were cast in Florida was very close to 6 million. It turned out to be a very tight election. Yes, now, the numbers I'm going to show you have been debated in many quarters. Many different counts have been provided with different numbers. But what all the protagonists have agreed is that whichever way these votes were counted, the difference between the candidates was of the order of a few hundred votes. Here is one such official count. Mr. Bush got very close to 3 million votes. Mr. Gore got very close to 3 million votes. As a proportion of the voting population then, each of them received very close to 50% of the votes that were cast. If for the numbers I've given you, Mr. Bush obtains just slightly more than 50%, a smidgen more than 50% of the vote. Mr. Gore, a smidgen less than 50% of the vote. Now, to get a feeling for the complication that this causes, let's take a look at a slightly more sanitized example, where two candidates are separated by 1% of the vote. Say one candidate gets 51% of the vote, or so, more precisely, 50.5% of the vote, and the other candidate 49.5% of the vote. Now, recall that in the process of polling, we're going to make errors. The more the data we have, the smaller the error we can guarantee. But take a look at the consequence of even a small error. Let's say an error of 1.5% in estimating a P, and therefore also in estimating a Q. If P, 50.5% in this example, is off by 1.5%, say it is on the low side, then what happens? Well, your 50.5% becomes 49%. And therefore, the Q, which was originally 49.5%, now increases by 1.5% and now becomes 51%. The roles of the candidates have now reversed. The candidate who was leading because of a slight error in the estimate is now the candidate who's following. And abruptly, our entire perception of who wins and who loses is now upside down. It's now clear what we need in our estimate. You see, the idea here is not just estimating a proportion, but estimating a relative proportion, not just estimating P or Q, but estimating a difference between them. We need an error which is no more than half the separation between P and Q, so that in the worst case, P can't edge more than half the distance towards Q, and Q can't edge more than half the distance towards P, keeping their relative ordering unchanged. And therefore, for a generic value for P and Q, we need an error no more than 1/2 of the absolute value of the difference between P and Q. Whether P is bigger than Q or Q is bigger than P makes little matter. It just reverses the roles of the protagonists. You want the error to be no more than half the separation. And in our example, with both P and Q wobbling just around 50%, whatever the count we actually adopt, it turns out the error epsilon we need is about something like 2 parts in 100,000. Oh, this is remarkable. This is really, really, really small. With such a small epsilon, if you say we want a confidence in our poll of 90%, recall the sample size by the Chebyshev estimate increases like the reciprocal of 4 times the square of the error times the confidence parameter. We plug in these numbers and we find that the requisite sample size for this tiny error, and with a confidence of say 90%, is in excess of 1 billion. Pause and look at this again. A sample size in excess of 1 billion to capture what 6 million people said. This is absurd. Remember, sampling ideally is going to be with replacement from the entire voting population. This is going to say that every member who voted in Florida should be queried on average 200 times, asking the same question each time: who won the election? And if you did that, and if they didn't get mad at you and throw you out, you would actually get a beautifully precise answer, and you'd be able to separate Mr. Bush and Mr. Gore. But of course, that is an absurd statement. Polling breaks when you need such accuracies. Now, in such settings, of course, the natural thing to do is to say, well, polls are useless, throw it out the window. just count everybody. Well, that's exactly what the election does, doesn't it? But we actually now run into a different problem. I alluded earlier to the fact that there have been multiple counts, and that the counts all gave slightly different answers. And the reason is that any counting procedure, whether it's human, in this case, as it was in Florida in 2000, or even if it's a machine-aided count, for example, a mechanical process or an optical, electronic process, any counting methodology introduces an error flaw, which is ineluctable, which is there as a consequence of nature. Life happens. The error flaw is typically of the order of a few hundreds in the order of millions. And so, for an election of this close a magnitude, no amount of counting is likely to have made much difference. The answers are going to be bobbling around back and forth, depending upon which way the counting errors took us. In such situations, the idea of an abstract truth is unachievable. The idea of who actually really won the election is forever not achievable. We've hit an ineluctable error flaw. Perhaps the only thing that one could do at this point is actually, and this is not what happened, of course, is to run the election all over again and hope that enough people change their minds that the difference between the candidate becomes more than a few hundred. So, here now is a refined slogan. It is certainly true that a small, honest, random sample gives us very good estimates with high confidence, irrespective of the size of the underlying population or their predisposition. But if one wants more than good accuracy, if one wants extraordinary accuracy, if one wants incredibly high precision, then random sampling and polling become untenable. We're going to have to count the entire population and try to keep the errors under control.